This one is an easy question, but it's a lovely question to consolidate our understanding about absolute values or modulus of numbers. What is the question? Is the product xy less than 0? As always, let's get clarity on how the answer to the question should be. For any yes question, for any be verb question, as we have seen, the answer should be a definite yes or a definite no. If you're able to answer the question from the information in the statements that the product xy is negative, we would have answered yes. It should be a conclusive yes. Then the data is sufficient. Conversely, if you're saying that no, the product xy cannot be less than 0, what does that mean? It's got two components, that the product xy could be greater than 0, as in this case, or the product xy could be equal to 0. In that case also, we'll be able to answer with a definite no. The operative word is definite yes or a definite no. If we find from the information in the statements that sometimes it's negative, the product, sometimes it's not negative, then the data is not sufficient. If you're answering with a maybe, which is when the data is not sufficient. Let's get started with the statements. Statement 1, say 5 into modulus of x plus modulus of y is equal to 0. Modulus of any number is not going to be negative. It can either be 0 or it can be greater than 0 because you're looking at only magnitude, the absolute value of the number. Here we have 5 into modulus of x, it's one number, and modulus of y, which is the second number. The sum of two numbers is equal to 0. When can the sum of two numbers be 0? There are two possibilities. The first one of the numbers is positive and the other is negative. The second one is both these numbers are 0. In the first instance, it's not just sufficient that one is positive, one is negative. Their magnitude should match. For example, if one number is a plus 7, the other number is a minus 7, then their sum is going to be equal to 0. The statement says 5 into modulus of x. Modulus of x cannot be negative, which means 5 into modulus of x cannot be negative. So this number is either positive or this number is negative or this number is 0. Similarly, modulus of y can also be not negative. It can either be positive or it can be 0. If both of them are positive, the sum cannot be equal to 0. So this is ruled out. So the only way to make the sum 0 is when both modulus of x and modulus of y, both of them are 0. Which translates to the case that x is equal to 0 and y is equal to 0. If modulus of x is 0 and modulus of y is 0, then x has to be 0 and y has to be 0. So the product xy will be equal to 0. If the product xy is equal to 0, it is not less than 0. Have you come up with a definite answer to the question? Yes, we are answering the question with a definite no. Statement 1 has given us a conclusive answer. So statement 1 is sufficient. What answer choices can we eliminate? We can eliminate B, C or E. What we are down to is A or D. Let's quickly consolidate whatever we have learned in statement 1 in a printed form in the next slide. Magnitudes, absolute values will always be non-negative. They can either be 0 or they'll be positive. If 5 into modulus of x plus modulus of y is equal to 0, with these two being non-negative parts, the only way it can happen is when both x and y are zeros, which translates to the fact that the product xy equals 0, which means it's not negative. We come up with a definite answer, so statement 1 alone is sufficient. In rule out choices B, C, E, we've narrowed the answer choices to A or D. 50-50 we have now. Let's evaluate statement 2 alone. Statement 2 alone is very similar. Modulus of x plus 5 into modulus of y is equal to 0. Both these parts, modulus of x and modulus of y, are non-negative components. So this is possible only when both x and y are 0. Again, the same reasoning, which means xy equals 0, xy is not negative. Statement 2 alone is sufficient. Statement 2 alone is also sufficient. At the end of statement 1, we narrowed our answer choices to A or D. Now we can rule out A because 2 is also sufficient. Choice D is the correct answer to the question.